हेलो एवरीवन, माय नेम इज़ करण मशरू। वेलकम टू दिस वीडियो। और इस वीडियो में हम बात करने वाले हैं अबाउट इंसर्टिंग अ नोड एट द एंड ऑफ अ सिंगली लिंक लिस्ट एट द एंड पोजीशन। ओके, सो बेसिकली लेट सपोज यू आर गिवन अ सिंगली लिंक लिस्ट जिसमें कि जो लिस्ट है अभी वो है 1 2 3 4 एंड 5 एंड नल। ओके, and this is the head pointer. Okay, and what you want is, let's say I want to insert a node with value 6 at the end. तो finally हमारी लिंक लिस्ट कैसी हो जाएगी? It would look something like this: 1 2 3 4 5 6 and null, राइट, एंड दिस वुड बी माई हेड पोजीशन। तो इसको किस तरीके से कर सकते हैं? सो बेसिकली सी, इनिशियली हमारे पास जो लिंक लिस्ट है वो ये है। ओके, सो लेट मी कॉपी एंड पेस्ट इट। ओके, सो व्हाट आई कैन डू इज आई कैन क्रिएट अ न्यू नोड with value 6. Let me call this temp and its next would be null. Right, now what I want to do is I simply want to connect the next of 5, that is the last node currently, to temp. As simple as that. If I connect this here, then my work is done, right? So in order to connect the next of 5 to this temp, I want the access of the node. I want the pointer pointing to 5. Let's say this pointer is p, so once I get it, then only I will say that p dot p next is equals to temp. Are you getting my point? So how to get access of this? We have only access to the head pointer in a single linked list. So I can take another temp pointer, let us call it temp1 or let us call it t. Okay, and I can, how to identify whether a particular, I will keep moving t forwards like how we move in the traverse function till we reach the last node. अब लास्ट नोड पहुंच गए कि नहीं ये कैसे पता चलेगा? अगर t नेक्स्ट जो है वो अगर नल है तो उस केस में हम कहेंगे कि t जो है वो करंटली हमारे लास्ट नोड को पॉइंट कर रहा है। अगर t नेक्स्ट जो है अगर ये नल नहीं है, then in that case it is not pointing to the last node and we should move forwards. Okay, so I can say while, so first of all I would say t is equals to head, right? So t is pointing here, and while t next is not equal to null, I would say t is equal to t next. Okay, so currently t यहाँ पे है, t next null है नहीं, t next null नहीं है, वो तो इसको पॉइंट कर रहा है. So let's say this location is 1000, this is 2000, this is 3000, this is 4000 and this is 5000. तो t next null नहीं है, t next की वैल्यू 2000 है, it's pointing to this node. So I will say t is equal to t next. So t next is currently pointing here, and I will say t is equal to t next, so t will come here. Okay, now again in the while loop, is t next equal not equal to null? Yes, so we'll continue the while loop and t will become t next. Now t next is not equal to null. Yes, this is true, t next is not null, so we will say t is equal to t next. Now t next is not equal to null. Yes, this is true, so we will say t is equal to t next, so t will come here. Now t next not equal to null, no, condition is false, t next is null, so we'll come out of the while loop. So when we come out of the while loop, our t pointer is pointing to the last node. Now I simply have to say t next is equals to temp. Okay, and before doing this, here I will create a new node with temp pointer having the value whatever I want to insert at the end position. Okay, so once I do this, t next equal to temp, so this will get connected here. Okay, and my head is not going to change in this case, so this will be my link list. So 1 2 3 4 5 6, so I have inserted a new node at the end position. Okay, now there is one corner case here. The corner case is, what if link list is already empty? So when link list is already empty, so your head is pointing to null, head is equal to null, right? And inserting at the end in a empty linked list means inserting at the front position, or basically inserting a node, right? At the end and front position are same. Now you see here, what issue you will get is, if you execute this code without checking head is null or not, you will say t is equal to head. Okay, then you will say while t next is not equal to null. Now t is equal to head and head is null, so t is null, and you cannot access next of null. See, if your t is null, head is null, so t will be null, and if t is null, you cannot say null next. Okay, that will crash. Okay, basically, so you need to handle this condition separately. So what you can do is, once you create this node with temp pointer, you can say if head is equal to null, in that case you can say head is equals to temp. Okay, and if head is not equal to null, in the else condition you can put this code. Okay, now what will be the time complexity? If there are n number of nodes, in order for you to reach from start, see, in order to, you need to reach till the end node, which this while loop will help you to reach, right? So the time complexity of this code will be big O of n if there are n number of nodes in the singly linked list, because you will have to traverse this n nodes first to reach your t pointer pointing to the last node, and once you reach there you will do this work. Okay, so this while loop is big O of n amount of time, and auxiliary space will be constant, and other operations are constant time, like t equal to head, t next equal to temp, doing this if else condition, right? So if this if condition is executed, it's a constant time work. But if I give a time complexity big O notation, worst case, then inserting at the end of the linked list will be big O of n, where n is the number of nodes currently in the linked list. Okay, now let's try to code it. Okay, so I have taken this code from the last video directly, where we have inserted this many nodes at the beginning, 10, 20, 30, 40, 50, 60, 70, and we called traverse head. So it printed 70, 60, 50, 40, 30, 20, 10, right? Now I will call head is equals to insert at end position head, comma, let's say 80, okay? And then I will copy paste this, and then I will say 90, and then I will say 100. Okay, and then I will traverse the linked list one more time. So when I traverse it another time, it should print what? 70, 60, 40, 50, 30, 20, 10, which I have done because of the inserted beginning, and then 80 is inserted at the end, then 90 is inserted after 80, and then 100 is inserted after 90. So 80, 90 and 100. Okay, so let's write this insert at end function. So I would say node star insert at end node star head and int x, right? So what I will do is, I will take node star temp is equals to new node with value x, जो कि हमें insert करना है, तो उस value का एक node create कर देंगे, and I would say node star t is equals to head. Okay, now if your head is equal to null, then in that case head is equals to temp, else I would say while t next is not equal to null, t is equal to t next. Okay, and then when I will come out of the while loop, t will be pointing to the last node currently in the linked list, so I would say t next is equals to temp. Okay, and in both the cases I will return the head pointer. Okay, so if the head pointer is modified, then that new head pointer will be returned. If that's not modified, then we'll return the original head pointer. Okay, now also this will be big O of n amount of time, where n is the number of nodes currently in the linked list. Now let's compile and run it. Okay, so let me write clang ++ insert at end.cpp -o insert at end.out. Okay, and now let's run it. /insert insert at end.out, and we can see we were able to insert. So basically first I called insert at the end 80, so 80 was inserted at the end of this linked list. So this 70 till 10 was created because of these operations, right? Insert at beginning, which we saw in the previous videos. Then I called a traverse, so it printed that part. Then I called insert at end 80, so 80 was inserted at the end. Then I called insert at end 90, so 90 was inserted, and then 100, so 100 was inserted. Okay, now let's also look for Java. So in Java, what I will do is, in this only I will make the changes. So here also what I will do is, here I will say I will remove one traverse, and I would say head is equal to insert at end head comma 80, and I would copy paste that, and this would be 90 and this would be 100, and I would call the traverse function for head one more time, just to cross check that our insertion has been done successfully. Right now I would say static node. I hope you have seen the previous videos. Okay, like using this class we are defining one node of a single linked list here, and we are using this reference to the next node. So static int insert at end node head and int x. Okay, so here I would say node temp is equals to new node x. सबसे पहले node create कर लिया, then node t is equals to head, and now if head is equal to null, in that case I would say head is equal to temp. Otherwise I would say while t next, now since this is a reference we use dot. Okay, we don't use the pointer, we do not use arrow is used for pointers. So while t next is not equal to null, I would say t is equal to t dot next, and then I would say t dot next is equals to temp. Okay, and finally I will return the head pointer. So as I said in previous videos also, we'll for this insert and delete functions, we'll try that we return the head pointer of the modified linked list from this function. Okay, so even if it is modified or not modified, we'll return it. Okay, now javac traverse dot java, and now I would say java traverse. Okay, and you can see 80, 90 and 100 are inserted at the end. Okay, I hope you have understood everything in this video. Thank you.